students, welcome to my space. It's your favorite science tutor, Professor Ernest. And in today's section, we want to look at a topic on the board called simultaneous linear equation. Simultaneous linear equation. Now, the word simultaneous has to do with concurrently, reoccurring. Now, when we consider simultaneous linear equation, linear has to do with straight line equations. They are simply algebraic expressions involving letters and numbers. So putting them together, we have simultaneous linear equations. They are algebraic equations, two or more algebraic equations that involves two unknowns. So we want to briefly look at simultaneous equation as a topic. And before we begin, it is vital for us to list some examples. Examples are, we have y plus x equals 2. We have 2y minus 3x equals 5. These are examples. These are linear equations. Two variables, y and x, raised to power 1. So 1 simply makes it a linear equation. 2y, the coefficient of y is raised to power 1, x is also raised to power 1. So equations like this, how do we solve such an equation involving two unknowns is what we want to look at. So we have various methods of solving simultaneous linear equation. Methods of solving, we have three basic methods. One, we have the substitution method. Two, we have the elimination method. Then thirdly, we have the graphical method. Now, for the purpose of this section, we shall be considering the first two methods. We shall be solving using the substitution method and also using the elimination method. Let us consider how each of these methods are applied. For example, when do we use the substitution method? When do we use substitution method? When do we use elimination method? An example, I'm given an equation like we have on the board, y plus x equals 2, then 2y minus 3x equals 5. Now, either of the methods can be used. I could decide to use substitution. I could also decide to use elimination. Now, to use substitution, many times when an equation is given, substitution, you consider the power. In this case, y is raised to power 1, x is also raised to power 1. The coefficient of y is 1, the coefficient of x is 1. In the second equation, the coefficient of y is 2, while the coefficient of x is minus 3. Now, you use substitution method when the coefficient of either x or y in one of the equations is unity. In this case, it is unity, so it is easier for me to use substitution method. So substitution method can go here. Another example is, assuming I'm having 3y minus 4x equals 15, then I also have 2y plus 3x equals 6. Now in this case, it will be preferable to use the elimination method. Why? Because I have coefficients. Y coefficient here is 3. Coefficient of x here is minus 4. You can see each of them have coefficient. Each of the letters will have coefficient. So whenever there are letters in front of, whenever there are numbers in front of letters, it is better to use the elimination method. So in this case, elimination method will work. Elimination method will be suitable for calculation. So we shall be taking a series of examples. So let's look at the substitution method. The first method we shall be considering is the substitution method. How do we use the substitution method? I have an example here. It says solve simultaneously. Solve simultaneously. We have x plus y equals 6 and 3x minus y equals minus 4. Now, like I said before now, whenever the coefficient of either x or y in one of the equations is unity, it is preferable to make use of the substitution method. So in this case, we have 1. So how do we solve such an equation? Solution. X plus y is equal to 6. I call this my equation 1. 3x minus y equals minus 4. I call this equation 2. Now, from equation 1, I'm going to make either x or y the subject. So assuming I'm going for x, so x becomes 6 plus y crosses over minus y. X becomes 6 minus y. This gives us equation 3. Then I'm going to say put equation 3 into equation 2. That means wherever I have equation 3, x equals 6 minus y, I'm going to put it in place of x in equation 2. This is what it means. I have 3x minus y equals minus 4 from equation 2. So 3x, x here represents 6 minus y. So 3 into 6 minus y minus y is equal to minus 4. Going to expand. This is 3 times 6, we have 18. 3 times minus y is minus 3y. I have minus y equals minus 4. So I have 18 minus 3y minus y gives minus 4y, which is equal to minus 4. So let's collect like terms from here. So I'm going to have minus 4y to be equal to, on this side I have minus 4. 18 crosses over, it becomes minus 18. So minus 4y is equal to minus 22. So I divide both sides by minus 4, minus 4. So minus cancels minus, 4 takes 4. So I have y to be equal to, this takes this, 2 in here is 11, 2 here is 2. So y is equal to 11 over 2. This is the value for y. So what next? What am I going to do? I'll go back to my equation 3 to find x. So I'm going to say from equation 3, where I have x to be equal to 6 minus y. So x is equal to 6 minus y is already 11 over 2. I'm substituting. So I take my LCM. LCM is 2. This is over 1. 2 divided 1 is 2 times 6 gives us a 12 minus 2 divided 2 is 1 times 11 gives us 11. So that makes x to be equal to 12 minus 11, 1 over 2. Therefore, it simply means that my x is equal to 1 over 2 and y is equal to 11 over 2. This is what we call solving an equation simultaneously, concurrently, one after the other. So at the end of the day, I've been able to get the two values that are obtained, that are supposed to be obtained. X is 1 over 2 and y equals 11 over 2. And so if I bring each of these values into the x equation, I'm going to get these corresponding values. So this is how we apply the substitution method in solving problems. I'm sure this is clear to us. Expect more videos in subsequent sections. See you there. Bye for now.